Hello everybody, this is section 7.2, part 1 video, and this is the law of cosines. We've already learned about the law of sines. Remember, when we use the law of sines, we have to have a known, I'm just going to use this picture here, we have to have a known angle and side relationship. And if we don't have that, we can't use law of sines. Law of cosines gives us another option. And I personally would use law of cosines in two different scenarios if I knew two sides and the included angle, side angle, side, or if I knew all three sides. That would be a time for me to use law of cosines. So before you write this in the yellow box, hold off on that for just a second. That is the formula that is provided by the textbook. However, I don't memorize those, all three of those. I memorize one of them, and you don't have to memorize any of them. They're going to be provided for you. You just have to know how to use them. So it's safe to say that not every triangle we come into contact with is going to be labeled with A, B, and C, and we're probably not going to always be solving for side A or whatever, okay? So other textbooks I have seen in the past have given these two formulas. I think these are the two I'd like you to write into your notes. You should have those handy when you're working on problems or when you're taking a lesson quiz or maybe anything like that, okay? So look at the pattern here. Solving for a side, this top formula should be the one that we should use. I'm solving for side A, and look at the other information in the formula. You must know the other two sides, and then you must know that angle that's in between those, okay? If we rearrange that formula in the top, if I tried to isolate for cosine A, I'd have to subtract some stuff. I'd have to divide by the minus 2bc part, and that's how we come up with this formula that's on the bottom. Now remember, we'll probably have to go further to solve for the side. Here you'd have to take the square root on both sides, and then in the second formula you'd have to take the inverse cosine. So there's going to be more to do there, and I would say the bigger challenge is just finding out what sides match to the particular formula. Okay, go ahead and hit pause and get a copy of this picture on your page. We are being asked to solve for the missing side and then use that information to solve for the triangle. So I have some funky labeling going on here. I do have B and A, but then I have a random X. We're being asked to solve for side X first. I think it's wise for me to go ahead and label the other sides. This guy is opposite angle B, so it makes it side B, and here's side A. Okay, so compare the formula that you just wrote down on the other page, from my other page. We don't have an X. We're going to be solving for side X though. So go ahead and write it as X squared. Then on the other side of the formula, the other two sides of the triangle are referenced. So right now what I'm doing is just filling in the law of cosines formula with the particular sides that match up with this problem. For the cosine part, you're going to have the same letter as the side that you're solving for, okay? So all I did was I took that formula, this guy, and I set it up with the appropriate sides for this particular problem. Now I'm going to do two things at once. I am going to square root to solve for X, and I'm also going to go ahead and go and substitute the numbers. Side A is 12, side B is 10. You'll notice we'll use those again, 12 and 10. And then the cosine of the included angle, which is 62 degrees. I would not recommend typing that in all at once. Okay, I would take some baby steps along the way. I'm going to trust that you can follow order of operations at this point in your math career. I would like to see on your papers at one point this. That tells me you know how to do the law of cosines. You followed order of operations properly. Okay, that's the point I would probably type all of that into my calculator. And when I do that and I round to the nearest tenths, I got 11.5. Okay, so we now solved for the missing side. We got that part done. Awesome. And now we're being asked to solve the triangle. So what's left for us to solve for are the remaining angles, angle B and angle A. But you'll notice what we've just done is we solved for one missing side where we knew the opposite angle. What that means is we can use law of sines for us to get another angle. Now, I want you to be wise about what angle you are choosing, and that is because law of sines has some restrictions. I'm going to write them down. There we go. We do not want to use law of sines to solve for an obtuse angle. We can't. And that it has to do with the range. I talked about this in a previous video. Has to do with the range of inverse sine. We won't be able to get an obtuse angle for that. The range of inverse sine is negative 90 degrees to 90 degrees. So we won't be able to get an obtuse angle. So what I mean by all of this is you want to be careful about which angle you're using law of sines to solve for. So how I'm going to choose between angle B and angle A is I'm going to look at side lengths and I'm going to choose the smaller one. Because if this is an obtuse triangle, which I don't think it is based on the side lengths, we could get in trouble if I tried to use inverse sine to solve for an obtuse angle. And the obtuse angle is going to be opposite the largest side. So that is why I'm going to solve for angle B next using law of sines. Sine of the known angle and side pair. Whoops, I was going to write 15.5, 11.5. That's the known ratio. We got to have that to use law of sines. I do not know angle B, but we're going to find it. And we know that that opposite side is 10. So there's the initial setup. Then you're going to cross multiply, and I'm going to trust that you know how to do that at this point. And we're taking the inverse sine. And when I did that, I found out that angle B rounded to the nearest whole degree is 50 degrees. I got lots of writing going on my triangle. This is 50. I know this guy's 62. All right, so we have one thing left to solve for in the triangle, and that is for angle A. And sure, you could use law of cosines or you could use law of sines, but I do not think that's the most efficient way because now I know two of the three angles. So I'm going to use triangle sum theorem. I'm going to take 180 degrees, remove the angle B that I just found, remove the given angle that I had, which leaves 68 degrees remaining. So angle A is 68, angle B is 50, and then we found that other missing side, X, was 11.5. Okay, so there was an example in which I used law of cosines to solve for a side, but then I used law of sines to finish it out. That's kind of my strategy. Law of sines is faster, so that's always my goal. Let's do a second different kind of example. For this one, find the missing angle and then solve the triangle. So those two law of cosines formulas that you wrote down, I'm going to now be looking at the second one. Our second one said cosine. It said angle A, but we're not solving for angle A, we're solving for angle P. So I'm going to write it with the appropriate letters. Now on the other side, it said B and C. So again, we have to match our example to the appropriate letters. Let's go ahead and get some labels on our triangle. And this is side P. Okay, so in the formula, it says cosine A equals, and then on the other side, they're using the other letters other than the angle. So we do not want to use P, we want to use Q and R. Q squared plus R squared. Now I'm going to subtract P squared. All divided by 2 times Q and R. That's the most challenging part for a lot of students, is matching the formula to the information that you're given in your example. Okay, so I'm going to do 2 steps in one here. I am going to solve for P by doing the inverse cosine, and then I'm going to substitute the numbers. So Q and R, that should be 5 squared and 8 squared. Do you see that those are the two sides that surround angle P? Then I'm going to subtract side P squared and then divide by 2 times the first two things I wrote in the top. Eventually you'll memorize it. I know it seems hard now, but you will memorize it. Carefully using order of operations in the interior there. And when I did that, I got 40 over 80, so 1/2. The inverse cosine of 1/2, you should know that without typing that in the calculator because that's on our unit circle. That tells us that angle P is 60 degrees. I'm going to label that in my picture. Okay, so we solved for the missing angle. That was the first thing we were asked to do. And now they want us to find the other, they want us to solve the triangle. So find the other missing stuff. So you'll see that once I've used law of cosines, I now have a known angle and side pair, which means that we could use law of sines to do more. We do want to be careful. Is that if this is an obtuse triangle, which I don't think it is that going to be where would be the largest angle? Well, here's the largest side. That means that R is the largest angle. I do not want to use law of sines to solve for that. So instead, let me get rid of that. I'm going to go to the smaller side and solve for angle Q next, using law of sines. Sine of the known angle divided by the known side. That's our pair, our known ratio. On the other side, sine of, I don't know angle Q, but I do know the side length. There's the set. Cross multiply and solve, and then you're going to have to take the inverse sine. Again, I'm trusting that you know how to do all that. Reach out to me if you do not. That's all from previous lessons. And when I did that, I got 38 degrees. So now I know that this guy's 38. Okay, so just like the last problem, yeah, you could definitely use law of cosines or law of sines to find angle R, but it's not the fastest way to do it. Use your triangle sum theorem. 180 minus the 60-degree angle minus the 38-degree angle leaves us 82 degrees remaining. So it was not an obtuse triangle anyway. Okay, last thing we have to cover is one more area formula. It's called Heron's formula. You know some ways to find area in a triangle already. You know that we can use 1/2 base times height, but that only works for us if we know the base and the height. Recently, we learned a new formula. It said 1/2 AB sine C. And that's helpful if you know certain information. Well, this is our last formula for area, and it's called Heron's formula, and it's helpful because we don't have to know any angle information. It is for an oblique, meaning a non-right triangle, and we'll use it when we know all of the sides. So I need you to write down this formula for area, but you might be questioning what S is throughout, and I'm going to talk about that now. S is called the semi-perimeter. Break that word down. Semi, you know that prefix, that means half. The semi-perimeter means find the perimeter and cut it in half. It's easy to find in a triangle, okay? That's the value of S. Let's look at an example. Here's a triangle, an oblique, a non-right triangle. Looks kind of right in the picture, doesn't it? We don't need to know. It's okay, we'll just use the sides in Heron's formula. So I know all three sides. That tells me that I can find the area using Heron's formula, but to start I need to find the semi-perimeter. And to do that, you're going to add up the lengths of all of the sides, and then you're going to divide, whoops, made that a little too big. Then you're going to divide that by 2. Well, that worked out nice and easy for us. Semi-perimeter is 10. So once you know that, set up Heron's formula. It says to take the semi-perimeter and then multiply each little individual part here, 10 minus one of the sides. Semi-perimeter minus another one of the sides. Semi-perimeter minus the last of the sides. And you can do the sides in any order there. Okay? Order of operations, we should work in the parentheses. This is 6 and 3 and 1. And when I put those all together, that's 180. And that is about 13.4 square centimeters. There's the area using Heron's formula. All right, we did it. 7-2 part 1 is done.